Hadean period, 4.6 to 4 billion years ago. No rocks on the Earth are this old except for meteorites. During Hadean time, the solar system was forming, probably within a large cloud of gas and dust all around the sun. The relative abundance of heavier elements in the solar system suggests that the gas and dust was derived from a supernova or supernovas, the explosion of an old massive star. Heavier elements are generated within by stars' nuclear fusion of hydrogen and are otherwise uncommon. We can see similar processes taking place in the so-called diffuse nebula in this and other galaxies. Because collisions between large planetesimals release a lot of heat, the Earth and other planets would have been molten at the beginning of their histories. Solidification of molten material into rock happened as the Earth cooled to 2.5 billion years ago. By the start of the Archean eon, the Earth's crust had cooled. The atmosphere was composed of volcanic gases including nitrogen, hydrogen, carbon, and possibly low levels of oxygen. Water vapor was abundant and the first oceans had formed. A complex set of chemical reactions in these early oceans transformed carbon-containing molecules into simple single-cell life forms. All life today is descended from these simple organisms. By the end of the Archean, the first photosynthesizing organisms had evolved and begun to produce oxygen, which was released into the oceans and atmosphere. This process would dramatically change life on Earth. Rocks of the Archean age contain the earliest fossils of life on Earth. Because these rocks were found a very long time ago, between 2.5 to 4.0 billion years ago, most have long since been covered by younger sediments, eroded, or subducted into the Earth's mantle. Nevertheless, some Archean strata survived in central parts of the continents. These Archean shields lie in the heart of Canada, Africa, Australia, India, and Siberia. Proterozoic period, 2.5 to 500 million years ago. The first traces of life appeared nearly 3.5 billion years ago in the early Archean. However, clearly identifiable fossils remain rare until the late Archean, where stromatolites, layered mounds produced by the growth of microbats, became common in the rock record. Stromatolites began to decline in abundance and diversity about 700 million years ago. A popular theory for their decline is that herbivores, eukaryotes, perhaps including the first animals, evolved at about this time and began feeding extensively on the growing stromatolites.
505 million years ago. The Ordovician period lasted about 67 million years. During this time, majority of the Earth was covered by the ocean. Most of the land was clumped on the supercontinent Gondwana, and even more of Gondwana was submerged underwater. Gondwana was slowly shifting towards the South Pole. The Ordovician period was a time period of many marine animals, one of the most famous being the trilobite. Most of the plant life around this time were algae and sea sponges. Life was thriving underneath the sea until Gondwana settled into the South Pole. Massive glaciers started to form, causing sea levels to drop. This massive change caused mass extinctions that resulted in 60% of the invertebrate genera to go extinct, therefore ending the Ordovician period.
438 million years ago. The Silurian period lasted 28 million years. During the Silurian period, the massive glaciers that formed during the Ordovician period started to melt. The melting of the glaciers caused the sea levels to rise a substantial amount. During the Silurian period, the climate was stabilized, so there weren't any more sudden climate changes. The Silurian period was also an evolutionary time period. During this time, we can observe the first fish who acquired jaws. Also, we can observe the first coral reefs that start to grow during this period, along with the widespread of crinoids and brachiopods. We can also show that life was on land during the Silurian period, mostly being fungi, the first arachnids and centipedes. Life was moving upwards and it was happening very quickly. 410 million years ago. The Devonian period lasted 55 million years. This period gave way to many small vegetation, only up to about a meter long. Near the end of the Devonian, there were the first trees, therefore creating the first forests. The Devonian consisted of two major animal groups on land. There were tetrapods, land-living vertebrae, and arthropods, including arachnids and wingless insects. There were three continental masses. North America and Europe sat together near the equator. Near the north, you had part of modern Siberia and one big continent composed of South America, Africa, Antarctica, India, and Australia sat in the southern hemisphere. The Devonian period was home to supercontinents Gondwana and Euramerica. The creation of these two supercontinents resulted in what we today call the Appalachian Mountains. A mass extinction occurred near the end of the Devonian. Mostly warm water marine animals were affected. Causes of this mass extinction included climate change, lowering of sea levels, and meteorite impacts, therefore ending the Devonian period.
355 million years ago. The Carboniferous period, also referred to as the Mississippian or Pennsylvanian period, lasted 65 million years. Climate around this time was a lot more tropical and humid than you would see today. Plant fossils that have been observed resemble tropical plants of today. The climate caused an expansion of the ocean that seemed to cover the entire globe, with exception to the supercontinent Pangaea that was coming together at the time. Fish from the Devonian period went extinct only to be replaced with modern-looking underwater plant life. Near the end of the Carboniferous period, there was an increase in erosion, which led to more floodplains and deltas. Freshwater clams made their first appearance along with bony fish and different types of sharks. Snails started to show up along with insects without wings that fold back like dragonflies. Anthrosaurus, with deep skulls and narrow bodies which gave them greater agility, appeared during the Carboniferous. There was a lot more loss in fauna than anything during the Carboniferous period.
290 million years ago. The Permian period lasted 40 million years, ending in the largest mass extinction ever recorded in the history of life on Earth. The extinction affected marine life drastically, almost wiping out all marine invertebrates of that time. Some groups survived, but in really small numbers. They never got back to the numbers they once had. This mass extinction led to the era of the dinosaurs. During the Permian period, the movement of Earth's plates brought most of the land together to create the supercontinent Pangaea. The rest of the Earth was covered by a single ocean called Panthalassa. Pangaea's middle ground was really dry, there was rarely any rainfall. This climate was, however, enough for the dinosaurs to survive. 250 million years ago. The Triassic period lasted 45 million years. This period was a period of transition. The climate and ocean circulation started to change. This period also followed the greatest mass extinction of all time. The greatest organism of its time had to be the dinosaur, who ruled the earth for 65 million years. They were one of the most successful groups of animals in terms of how long they lived. One of the most famous dinosaurs being the Tyrannosaurus rex, or the T-Rex. This ginormous carnivore ruled from 85 to 65 million years ago. Being the kings of the land, they probably never expected to be taken out the way that they did. 205 million years ago. The Jurassic period lasted 70 million years. When I say Jurassic, you probably think of the movie Jurassic Park. Dinosaurs did rule the land at the time, though. Instead of dinos such as the Triceratops, we had dinos such as the sauropod, the largest dinosaur. The first birds started to show up during the Jurassic. Not only was the land thriving, but also the sea. There were giant cephalopods like ammonites and belemnites. Those are squid-like creatures. There weren't any palm trees, but we had cyadioids and ferns. Close enough, right, Hollywood? The Cretaceous period lasted 75 million years. also called the last age of the dinosaurs, but that doesn't mean that new kinds of dinosaurs didn't appear. The breakup of the world continent Pangaea, which also began to disperse during the Jurassic, continued. This led to increased regional differences in floras and faunas between the northern and southern continents. The most famous of all mass extinctions marks the end of the Cretaceous period. About 65 million years ago, as everybody knows, this was the great extinction in which the dinosaurs died out, except for birds, of course. A large meteorite hit the Earth, causing climate change and famine, and over time killed the dinosaurs. 65 million years ago. The Tertiary period lasted 63.2 million years. It was an interval of enormous geological, climatic, oceanographic, and biological change. They were the first mammals who lived in a cold, glaciarized world with very low sea levels. It spanned the transition from a globally warm world containing relatively high sea levels and dominated by reptiles to a world of polar glaciation and sharply differentiated climate zones and mammalian dominance. This happened when 80% of the population died, including the dinos. This period gave birth to modern glaciers and primates who will go on to be 1.8 million years ago. The Quaternary period is still going on today and has been characterized by several periods of glaciation wherein ice sheets many kilometers thick have covered vast areas of the continents and temperate areas. During and between these glacial periods, rapid changes in climate and sea level have occurred and environments worldwide have been altered. These variations, in turn, have driven rapid changes in life forms, both flora and fauna. Beginning some 200,000 years ago, they were responsible for the rise of modern humans.